On CP3-2 part 2, we're going to take CP3-2 part 1 a step further, and once we've found the perpendicular bisectors, we'll use them to find the circumcenters. So as to find the point of intersection of the perpendicular bisectors of two line segments. So we're going to start by figuring out, okay, what are the actual perpendicular bisectors? So just like yesterday, I need the slope, the perpendicular slope, and the midpoint. And I'm going to need that for both equations. So the slope between the first two is 8 over 4, or negative 8 over 4 rather, or negative 2, which is positive 1/2. And if this is looking awfully familiar, it's because this first line is the same one you solved yesterday. And the midpoint there is 8, 4. So I'm using the perpendicular slope and this point to write an equation. I'm going to write it as y minus 4 equals positive 1/2 times x minus 8. I need to take this a step further now. Okay, so I'm going to go ahead and distribute and add the 4 over. So this equation will turn into y equals 1/2 x minus 4, but then I'm adding the 4 over from this side. So I really get y equals 1/2 x. And I'm going to hang on to that. That's the equation I'll come back to. In my second line, my y's are going up 2 and down 4. So that's a negative 1/2, which means my perpendicular slope will be positive 2. The midpoint will be 2, 3. So I'm using that point and that slope. Again, I'm going to start in point slope form, so I'll have y minus 3 equals 2 times x minus 2. And then I'm going to distribute and add the 3 over. So I get y equals 2x minus 4 plus the 3 to move it away from the y. So my final equation that I'll be using is y equals 2x minus 1. I want to know where these two lines meet. Right now I have them both set up to be y equals something and y equals something else. Well, if these two things both equal y and I want to know where y is the same, I'm going to set them equal and solve. So I'm going to say 1/2 x equals 2x minus 1. And the first thing I'm going to do anytime I have a fraction is clear that fraction. So I'm going to multiply both sides by 2. That will drop out and I'll get x over here. Distribute that and I have 4x minus 2. If I subtract my 4x, I get negative 3x equals negative 2, which means x must equal 2/3. Once I know what x equals, I can pick my favorite equation, and my favorite one is that blue one because it has fewer fractions. And I'll have y equals 2. Take this value for x and plug it in. And now I can solve for y. So I get y equals 4/3 minus 1. 3/3 is the same as 1. So then y has to equal 1/3. I'm going to write my answer as an ordered pair. So my final answer is 2/3, 1/3. On this next one, we're asked to find the point of intersection of the perpendicular bisectors of the triangle with the following vertices. Okay. We're going to do the exact same thing that we did yesterday. We're going to find the perpendicular bisector equations. Then we're going to do what we just did above, pick two equations and set them equal. So I still need to find the slope, perpendicular slope, and midpoint of each one. So between A and B, my y values are going up 2. My x values are going up 6, so that slope is 1/3, which means my perpendicular slope is -3, and my midpoint is 1, 2. Use your perpendicular slope and your midpoint to write an equation. So I'll get y minus 2 equals -3 times x minus 1. And then take that equation, distribute that -3, and add on the 2. So I end up with y equals -3x plus 3 plus 2. When I combine those like terms, I get plus 5. I'll do the same thing with B and C. So from B to C, my y value is going down 2. My x value is going down 8. So that slope is 1/4. My perpendicular slope then is -4. My midpoint is 0, 2. Use your perpendicular slope and your midpoint in point slope form. So I get y minus 2 equals -4 times x minus 0, which very quickly becomes y minus, or equals -4x rather. Because there's a 0 there, I don't need to worry about distributing to that. And then I can add the 2 over to get away from the y. I'm going to find all 3 on my practice. On your test, you'll only be asked to find 2, but it's good practice to find all 3, and sometimes it is easier to use certain equations than others. So my slope between A and C, my y's are going up 0, my x's are going down 2, so that slope is 0, which again means this is undefined. My midpoint will be at -3, 1. Anytime I have an undefined slope for that perpendicular, I'm using x equals and then a number. And it will always be whatever x value is the midpoint. So I'll have x equals -3. And then I'm going to pick 2 equations to set equal. I could set the orange and the green equal to solve for x, but I already know what x has to equal, right? It has to equal -3. So I can write part of my answer, and then I can pick one of my equations, and I'm partial to that green one, and I can say, all right, y equals -4 times -3 plus 2. And now I can just solve for y. So I'll have y equals 12 plus 2, y equals 14. And there's my final answer. On this third problem, we're going to use the verbiage that you will see on your test and on your checkpoint, which is to find the circumcenter. The circumcenter is just, hey, where do the perpendicular bisectors meet? So it's exactly what we've been doing, so don't let big fancy words scare you. As with before, we're going to find the perpendicular bisectors of each line. So I'll need the slope, the perpendicular slope, and the midpoint, and then I'll find where they are equal. I'm going to start with DE. The slope between D and E, my y values are going up 12, my x values are going up 4, so that is 3. The perpendicular slope then has to be -1/3. The midpoint will be at 2 and 0, and again, these should be familiar because we've used them yesterday. If not, go back and watch those a little bit to kind of brush up on how I'm doing this. I'm using my perpendicular slope and my midpoint in point slope form. So I'll have y minus 0 equals -1/3 times x minus 2. I'll rewrite this now by distributing, and I don't really need to add that 0, so I won't do that. So I'll get y equals -1/3 x. -1/3 times -2 is a positive 2/3. I'll keep that equation at the back of my mind, and I'll do the same thing with EF. My y value is going down 6. My x value is going up 8. So that's negative 3/4, which means my perpendicular slope must be 4/3. My midpoint between E and F then, 4 plus 12 is 16, cut in half gives me 8. Halfway between 6 and 0 is 3. I'm using my perpendicular slope and my midpoint in point slope form. So I get y minus 3 equals 4/3 times x minus 8. And I'm going to distribute and add on that 3. So this equation becomes y equals 4/3 x minus 4 times 8 is 32. So I'm going to leave it as 32/3. And then I'm adding on 3, but I'm going to think of it in terms of thirds so I can combine like terms. 9/3 is the same as 3. So I'm going to add 9/3. So this equation really is y equals 4/3 x minus 32, negative 32 plus 9, rather, bring me to 23/3. And it feels icky and gross, but we're just going to leave it for now because when I solve, my very first step will be to clear my fractions. So I'm going to find one more line, and hopefully it's a little bit nicer than that last one. That slope is going up 6, and my y value is going up 12. So that is 1/2. My perpendicular slope then is negative 2. My midpoint halfway between 0 and 12 is 6. Halfway between negative 6 and 0 is negative 3. And I can already tell this is going to be a much nicer equation. So I'll get y minus a negative 3 becomes a plus 3 equals negative 2 times x minus 6. Rewrite that equation. I'm going to distribute the negative 2, so I get y equals negative 2x. Negative 2 times negative 6 is positive 12. And then I need to subtract the 3 to get it away from the y. So I end up with y equals negative 2x plus 9. I want to know where these 3 lines meet, but I don't need to use all 3 to do it. Okay, so I'm going to pick the 2 nicest ones and set those equal. And I think the green one's the nicest because it doesn't have any fractions. And I also like the blue ones because they're all proper fractions. It's not quite as scary. I want to know where y is the same in them, so I'm going to set negative 1/3 x plus 2/3 equal to negative 2x plus 9, because we're assuming y will be the same. I'm going to solve for x. Once I know that, I can plug it into one of them and solve for y. So the first thing I'm going to do is clear my fractions. And that means I'm going to multiply everything by the denominator of any fractions that I have. So that'll cancel out and that'll cancel out because I'll distribute here and here. So I'm really only going to have negative x plus 2 equals negative 6x plus 27. I'm going to add the 6x over and get 5x, subtract the 2 equals 25. And then I get x equals 5. Again, I think that green equation is the nicest one. So I'm going to use y equals negative 2 times 5, plugging that x value I just solved for in, plus 9. So I'll get y equals negative 10 plus 9, which means y must equal negative 1. So my final answer, as an ordered pair, is my x value 5 and my y value negative 1.